In section 7, we're taking a look at another way to display data, which is called a box plot. So this right here is a box plot. And in the box plot, we have, basically it's called a 5-number summary. We're looking for 5 quantities: a minimum value, a maximum value, a median, quartile 1, quartile 3. When we set this up, we always get this box shape. So our minimum value is always going to be down here, maximum value up here, and then these 3 numbers right there are the quartile 1, median, and quartile 3. Now the way the data breaks down is that 25% of the data on average will fall in between minimum and Q1. 25% of the data will fall between Q1 and Q2, which is the median. 25% of the data will fall between the median and Q3, and then the remaining 25% of the data will fall between Q3 and the max. And that's excluding what are called outliers, and we'll talk a little bit more about those in a little bit. But first, let's take a look at a 5-number summary and how to create the box plot from that. So here we have a list of numbers, 13, 15, 19, and so on. We're going to find some of the easy ones first. These are in order, which is very nice. It's easy to find the min and the max. Not a whole lot of work to do to find the median either. The minimum value is the lowest value we see, which would be 13. And our max would be 41. To find the median, we're looking for the middle number. So 1, 2, 3, 4, 5, 6, 7 numbers. So we're looking for the 4th number. And there is our median value. To find Q1 and Q3, now you notice that the median will kind of divide the data into 2 halves, an upper half and a lower half. To find quartile 1, which is the lower quartile, we're basically going to find the middle or the median of the lower half of the data. Now, because we know what the median definitely is, we don't include that as being part of the upper half or lower half, because it really isn't. It's right in the middle. So if I'm looking just at these lower numbers here, let me circle those guys, 13, 15, and 19, the median of that set of data is 15, so that ends up representing quartile 1. Looking at the upper half of the data, 27, 33, and 41, the median of that would be 33. Okay? So what we're going to do next is we're going to create the box plot from this. So what I'm going to do is take the minimum value, and I'm going to put a line at 13, which is somewhere between 10 and 15. I'm going to take Q1, which is at 15. Median is at 23. Upper quartile is at 33. And then the maximum is at 41. What we're trying to do is create a box plot similar to what we have up here. So the numbers on the end represent that final bar, and in between the next numbers, we've got that line. So I'm going to draw a line here and here, and then the rest of it will create this box. And then so that's our our box plot for this 5-number summary. Again, 25% of the data on average in here, 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 and also there. Our second set of data is a similar type of structure where you have, I think, 9 numbers here. 5, 6, 7, 8, 9. Yes, we do. Our median will be this number right here, 45. Our minimum is 21, max is 82. And to find the lower quartile, again, we're trying to find the median of the lower half. So in this case, we have 4 numbers. To find the median, we have to find the average of these 2 right here, these guys. So if we take 28 and 35 and add those up, we get 63. Dividing by 2 gives me 31.5. And I'll do the same for the upper half of the data. So again, 2 numbers in the middle, 59 and 71. When I average those out, I get 65. So I can set up my box plot from this. So I've got 21 as my minimum, 82 is my maximum, lower quartile 31.5, so somewhere in that area. Median is 45, upper quartile 65. So once again, this number right here, 21, is our minimum value. So we're going to draw a line. There's our maximum value. Draw that line. And then the in-between stuff creates the box. So what happens when we don't have definite median, a number in the middle that we can actually find? Well, in this case, we have 6 numbers. We know our minimum's 18. We know our maximum's 81. Our median will fall in between here, between 52 and 61. So when I average those out, I end up getting 56.5. Now, here's where it gets interesting, though. I don't actually have the median as part of my data point. So when I'm trying to set up my lower half and my upper half, I do actually include the 52 and the 61. They're part of a half because we don't have the definitive median, the number right in the middle. We use these to calculate it, but we weren't given the median. We had to actually find it using those numbers. This sets up the lower half and then the upper half. So when I find the middle of the lower half, I get 31, and the middle number in the upper half is 72. So just like we did before, we're going to set up our box plot with a 5-number summary. 18 somewhere in there, 31 about there, and 56.5, 72, and 81. Connect those, and connect those. And there's my box plot for those numbers, for the 5-number summary. Now in activity 3, we looked at how do we have, or where does the data fall, percentages, numbers, all that other good stuff here. Just like we talked about before, the box plot will break things up into 4 parts. 25%, 25%, 25%, 25%. It's the same throughout. So when we have this box plot down here, those percents don't change. All of it's 25% for each of those chunks. So on this problem here, we're looking at the box plot below represents the number of minutes that students spend eating dinner on an average night. Question 1 says, what percent of students take between 12 and 18 minutes to eat dinner? Well, between 12 and 18, and I'm going to highlight this, that's that chunk right there. So that's one piece of that box plot. So then that would be 25%. Question 2 says, what percent of students take between 18 and 20? So again, one piece right there, 25%. 3 is a little different because now they're saying there are 80 student survey. We know how many people responded to the survey. How many of them, not percent, but how many of them spend between 26 and 36 minutes? So if I highlight that, the 26 to 36 minutes, that's one piece, that's 25% again. However, I want to know how many people actually did that. They might think of this in 25% in terms of fourths. It's 1/4 of the data set. Or, if we like it in terms of decimals, 25% is 0.25, which we can then multiply by how many were surveyed, which is 80. And when we multiply those together, we end up getting 20. Number 4 says if 130 students respond to the survey, how many spent 18 to 26 minutes? So let me grab my highlighter here. Let's go, let's try a different color. Let's go orange this time. Between 18 and 26 minutes, that's 50% because it's got 2 pieces of that box plot. So I'm going to take that number, oops, highlight that one first. 50% is 0.50, and I'm going to multiply it by 130 students, which gives me 65. So 65 students, if 130 were surveyed, would spend between 18 and 26 minutes eating dinner. Now we want to compute the range of the data. The range is the high minus the low, and this one should be a relatively easy one for us to calculate. Our high number was 36. Our low number was 12. So our range is 24. What we'll calculate next is leading us into what are called outliers and trying to figure out if data doesn't really fit. It's there, but it doesn't really fit what we expect it to be. So the interquartile range is kind of the key piece to all this when we're trying to find the outliers. And just like the range, the interquartile range is going to be a subtraction of a high minus a low. But instead of looking at the highest number overall, we're looking for the highest quartile, which in this case would be Q3. And then we're going to subtract off the lowest quartile, which is Q1. So to find the IQR, or interquartile range, we take 26 minus 18, and we get 8. We're going to use that number to try and find some outliers, some numbers that don't fit, or shouldn't fit anyway. So what we're going to do next, if you notice these two formulas that we have down here are all kind of basically the same kind of thing. They both have a 1.5 IQR, so we're going to take our interquartile range, multiply it by 1.5, and then we add it to Q3 to find an upper outlier, and we subtract it from Q1 to find any lower outliers. So let me multiply 1.5 times IQR first, which we said was 8, and that's 12. So if I want to find the higher the higher outliers, I'm going to take this Q3 plus 1.5 times IQR. Q3 we said was 26 plus 12, 38. I do the same thing for Q1, but instead of adding 12, I'm going to subtract it. Q1 was 18, so when I take away 12, that gives me 6. What that tells me then is that if someone were to take less than 6 minutes to eat dinner, holy cow, that's like no time at all, they would be considered an outlier. Anyone that takes more than 38 minutes would also be considered an outlier. Jeremy was absent on the day of the survey. He spent 93 minutes eating dinner on an average night. Is Jeremy an outlier? Yes, very much so. So yes, because he spent more than 38 minutes. 38 was the outlier, or the high end of the outliers. He spent 93. So, yeah, he's definitely an outlier. So again, on this box plot video, what we took a look at was how do we calculate the 5-number summary? So min, max, median, Q1 and Q3. How do we create the box plot? And then how do we use that box plot to figure out where data falls?